with changes in temperature, we're experiencing other changes in climate, like sea level rise, declines in Arctic sea ice, wildfires, heavy precipitation events, and more. At NASA, we're observing the Earth so we can understand both what's happening today, but also how that's changed over time. So we can observe the impacts of climate change, like sea level rise, wildfire, extreme heat. We can also observe the drivers of climate change, like greenhouse gases, carbon dioxide and methane, that are increasing in the atmosphere and trapping heat. By observing this, we can understand both what is happening now and also why it's happening, and provide that information to inform decision makers and the public. So all of the data that NASA collects is publicly available, and we're working to make it easier to use so that people can understand what's happening in their communities and help plan for the future. And what you'll hear about today is a little bit more about the recent records and predictions of the future. And so I'll turn it to Dr. Gavin Schmidt to talk about recent data and observations.
Thank you very much, Kate. So we are producing today the GISS temp analysis of global temperature anomalies. These are an analysis based on weather station data, ocean buoys, ship records, and automatic weather stations in Antarctica and elsewhere, put together to give an estimate of the global mean temperatures, and that estimate goes back to the 19th century. The results that we're presenting today for July show that July 2023 was by far the warmest July in the record, more than 0.2 degrees Celsius warmer than the previous record, which was in July 2019, and more warm still than the last time that we gave a kind of mid-year press briefing on the temperatures, which was in July 2016. The temperatures in July are warming very, very clearly. What we're seeing here is anomalous, so it's above the trend that we would expect just from an extrapolation, and that's related to what's going on in the Pacific. So we have an incipient El Nino event that is happening, though we anticipate that the impacts of that El Nino event are going to build over time as we get towards a larger event towards the end of the year. And the biggest impact of El Nino will actually occur in 2024. So we're anticipating that not only is 2023 going to be exceptionally warm and possibly a record warm year, but we anticipate that 2024 will be warmer still. There are other things going on beyond El Nino. We're seeing extreme temperatures in the North Atlantic and in other parts of the ocean. These have been building for a while. You would have seen some discussion of that since March. There's a persistence to the sea surface temperature anomalies that is helping fuel the warmth in July and through the rest of this summer. And one of the things that comes from that is because July and August are generally the warmest months of the year in the global mean, and that's because of the asymmetry between the northern hemisphere continents and the southern oceans. That means that this month is the warmest month in absolute terms in the record going back to the 19th century, though it isn't the warmest anomaly. So we've had bigger anomalies in February and March associated with the last big El Nino event in 2016. But what we're seeing here is the warmest absolute temperatures, and we know that that's having impacts. Kate mentioned it. We know that is inducing heat waves. We know that it is leading to more intense rainfall. And we're seeing that very in many places in the world, and we know that it is a contributing factor to the growth of wildfires in areas that have been affected by the temperatures. Thank you.
Thanks a lot, Gavin. The oceans are experiencing about 90% of global warming. The last 10 years have been the warmest since the 1880s. And all these increases in temperature are not only felt at the surface of the ocean, but they can only be detected at thousands of meters depth. And there are consequences. As the oceans heat, the water expands, and when you combine that with the melting of ice over land, that contributes to increases in sea level rise, which are accelerating. And of course, the consequences are increases in coastal flooding, coastal erosion, and as an example, places like Miami Beach, they have been experiencing more frequent coastal flooding, only what we call, blue skies, about 5 times more than what they experienced 15 years ago. The marshes in Louisiana are disappearing also, in part also caused by the increase in sea level. Biology of the ocean also suffer consequences, right? These increases in temperature that we are seeing in Florida recently, with measurements approaching 100 degrees, exceeding 100 degrees in some areas, are bad for organisms. Not only are we seeing an increase in the frequency of coral bleaching, but we're also seeing coral, fish, and seagrasses die off. In other places like the East Coast, marine species of economic importance are migrating to colder waters. They're either moving north or going deeper. Unfortunately, coral reef cannot grow legs and move away. So they have to stay put and experience the brunt of global warming. To add some insult to injury, all this CO2 that we are putting in the atmosphere also dissolves in the water and acidifies it. The ocean waters are about 20% more acidic than at the beginning of the industrial period. And this is not good for corals. And many other microscopic marine species that are at the bottom of the food web are also affected by ocean acidification. Now, coral reefs are not just these pretty things that are there for tourists to go and look at them. They are super important for the marine ecosystem. About 25% of marine species have something to do with corals. They contribute with medicine. They contribute with livelihood to millions of people. They protect the coastline from tidal surges and storms. So they are key to the health of our marine environment, and they need to be protected. Fortunately, NASA, NOAA, and friends and family in other national and international agencies have been collecting crucial data to understand how the Earth is evolving under climate change. And more crucially, we continue to work in the development of advanced measurements so we can understand our planet even better. Next year, for example, we are planning to launch the PACE mission, which will provide unprecedented measurements on the biology of the ocean, not only to understand how it works, but how it will react to global warming. And simultaneously, it will collect measurements of the atmosphere so we can look at how this atmospheric ocean system works. We're working on the GLIMMER mission, which will provide very detailed measurements of our coastal environment, which are the ones that are feeling the brunt of global warming right now. And of course, NOAA is working on another mission like GeoXO, for example, which will provide continuity of measurements so in the future we can continue to study how our planet is evolving. And remember, these increases in extreme events not only affect the coast, they are also felt hundreds of miles inshore. So what happens in the ocean does not stay in the oceans. Okay? It affects the whole planet. So we continue to provide this crucial data so our decision makers, our policy makers can go ahead and do their job. Now I would like to leave you with Sarah, the Chief Scientist of NOAA, who will talk more about these issues.
Our data indicates that July 2023 was the warmest July on record for the globe, and it was the warmest July by a long shot, specifically by more than 1/3 of a degree Fahrenheit. That may not sound like a lot, but the margin for most global records is on the order of 1/100 of a degree or two. So last month was way, way warmer than anything we've ever seen. The warmest month of the year for global temperatures is also typically in July, just like it's usually the warmest month of the year for most places in the United States. Given that July 2023 was the warmest July on record and July is the globe's warmest month of the year, it's very likely that July 2023 was hotter than any month in any year since at least 1850. Having said that, the really important thing to remember is that July 2023 is just the latest in a long run of extremely warm months and years going back several decades. In other words, the long-term increase in global temperature marches on and on and on. We have now seen 47 consecutive Julys that are above the 20th century average and 533 consecutive months above the 20th century average. It's also worth thinking about El Niño and its impact on things going forward, as Gavin mentioned. El Niño tends to increase global temperatures, albeit with a several-month lag, meaning it probably did not have much of an impact on this July record. Given NOAA's forecast right now, there is over a 95% chance that El Niño will continue through the winter. We could see even bigger impacts in the winter and spring as El Niño peaks. While El Niño might not have had much impact on air temperatures, it did contribute to the record-breaking global ocean temperatures. For the fourth consecutive month, the global ocean surface temperatures hit a record high as El Niño conditions that emerged in June continued into July. Over 40% of the ocean is currently experiencing a marine heat wave, with our predictions showing that that could continue into the fall or even expand. Meanwhile, in the far south, Antarctic sea ice coverage ranked the lowest on record for the third consecutive month, contributing to the July 2023 setting a record for the lowest global July sea ice extent on record. Putting all of this together, 2023 to date has been the third warmest on record. According to NCEI's Global Annual Temperature Outlook and data through July, it is virtually certain, over 99% chance, that 2023 will rank among the 5 warmest years on record, with a nearly 50% probability that 2023 will rank warmest on record. El Niños can temporarily warm the globe by approximately 0.1 degrees Celsius, an equivalent to the expected warming over a 10-year time horizon. A year like this gives us a glimpse into how rising temperatures and heavier rains can impact our society and stress critical infrastructure over the next decade. It's important to remember that these years will be cool by comparison by the middle of the century if we continue to warm our planet as greenhouse gas emissions continue. Put another way, the next few years will be the coolest for the rest of my life if the world continues to emit greenhouse gases into the atmosphere. Thank you.
Thank you all very much. We will now take your questions. You can press *1 to enter the question queue. Our first question is from Jim Siegel with NASATech.net. Jim?
Thank you for taking my question, and thank you for doing this session. I'm planning to do an in-depth story about climate change, and I'm curious about where I can go to get the base data from which the conclusions are derived that you described today. Is that in the is that in the database that Bill mentioned earlier, or what? And I'm kind of curious too about how far back reliable temperature data exists in the United States. Thank you.
Gavin, do you want to take that one?
Sure. So the data that goes into the GIST temp product is all available at data.gis.nasa.gov/GISTtemp, and all of the data and uncertainties and analyses can be downloaded there. You can do the whole thing again if you want, but you can just get the answers if you want. The temperatures in the US are actually pretty well sampled, even going back to the mid 19th century, and so the CONUS temperatures go back easily to the mid 1800s. For other parts of the globe, it's not quite so well sampled, particularly in the southern hemisphere pre-1920. But we have a reasonable estimate of global mean temperatures going back. We cut it off at 1880. Our colleagues at NOAA go back to 1850. And there's another product from Berkeley Earth that tries to go back even further. But the uncertainties increase as you go back in time.
Thank you very much.
Thank you.
Our next question is from Rachel Ramirez with CNN.
Hey, everyone. Thanks for doing this. Administrator Nelson mentioned the fires in Hawaii, and, the death toll is climbing each day, so this isn't going away anytime soon in the news cycle. So I was wondering if we could touch on that a bit more in the context of the global climate records that you all just laid out. And I'm curious if NOAA or NASA is gathering more data in terms of kind of establishing that climate change connection with the fires, and are there any scientific initiatives also being affected by the fires on the ground in Maui right now?
Gavin has his hands up. And also, Sarah.
Do you want to go to Sarah first?
Sure.
So this will be heavily studied. There will be a lot of research that comes out of both NOAA as well as our sister agency and Department of Commerce, NIST, who studies the wildfires and the effects of these things, in understanding specifically what caused this and the events that we've seen. Additionally, there was also drought present, which made it the dry conditions right in advance of it as well.
Thanks, Sarah. And Gavin?
Yeah, I mean, I think it's very important to note that when we have a disaster such as this, there are many antecedents. There are many little things that happened that give rise to these kinds of things. And so, there are local situations right on Maui that relate to abandoned sugar plantations, non-native grasses, the high growth of grass in the spring, the drying out that Sarah just mentioned there. But you've also got longer-term trends. You've got longer-term trends in rainfall. So storm tracks have been moving north with climate change. Hawaii has been getting, in general, less rainfall decade by decade. And so there are long-term effects that are contributing, but then there are going to be local and very specific precursors, including the ignition, that lead to any particular configuration. But what it is that you have to, I think, remember is that, there are lots of local things happening all around the world for all of these different things. But in general, climate change is a kind of threat multiplier for wildfires. And so there is an overall tendency that we will increasingly see towards greater and more intense wildfires that will be caused by climate change, whether this particular example, how much of a contribution it is, that is going to be something that we're going to be looking at very, very carefully in the future.
Thank you very much. Just a reminder to our folks on the line, you can press *1 to enter the queue. We have another question from Jim Siegel from NASATech.net.
Thank you. Have you drawn any conclusions about how much of the warming you've described is man-made and has a man-made impact as opposed to the natural temperature cycles of the Earth? Thanks.
Yes, we have. We've been looking at this attributional problem for many decades now. And what we found is that the long-term trends that we've been seeing since the 19th century, particularly since the 1970s, they are all due to anthropogenic effects. The impacts of internal variability, the impacts of El Nino, the impacts of volcanoes, all of these things are very, very small compared to the anthropogenic component. And that anthropogenic component, the human part of this, is driven mostly by greenhouse gases, carbon dioxide the first, methane the second, chlorofluorocarbons the third, also ozone, and then changes in air pollution, deforestation all help. But all of those things are human created. And so without those human contributions to the drivers of climate change, we would not be seeing anything like the temperatures that we're seeing right now.
And Sarah?
Thank you.
Using both observations and being able to do statistical analysis on that allows us to also say what is the natural variability versus this response that we see that is so outside that envelope of the past historic variability. And as I said in my remarks, El Nino only increases the temperatures by roughly 0.1 degrees Celsius, and the warming is so far exceeding that. We also have models which are really critical for us to understand natural variability and the forced response that we see to human emissions into the atmosphere. And that, too, in recent decades, the temperatures that we are now experiencing, you can only get those temperatures if you include those greenhouse gas emissions into the atmosphere and the land use change that we have created on Earth. And so as a result, you only get the temperatures that we have right now, this enhanced warming, this value that is so far exceeding what our natural climate would be. So we are in a different climate state as a result right now.
Thank you. Kate?
Yeah, and just building on what both Sarah and Gavin said, as scientists, we're continually looking at what's happening on the Earth and what's causing those changes. And we use multiple lines of evidence, is what we refer to it in science. So different ways observing the Earth. You add in models to complement observations. We have laboratory experiments where we can replicate the sorts of effects that we're seeing. And when we bring all that together, what we're seeing is that human activity and principally greenhouse gases are driving the changes we're seeing on the planet.
Thank you all so much. And we do not have any more questions. So you can play back this media event on nasa.gov/live and also learn more about our climate work at nasa.gov/climate. Thank you all so much.
Why does climate